In this next example, we'll be trying to say something about a whole class of functions of the form 1 over x to the p. And an interesting question, and one that will be useful for us in the future, is to think about for which values of p will this integral converge. Because we've already seen two examples of some members of this family of functions. For instance, we had when p is equal to 1, we showed that this integral is divergent. We showed this one equals to infinity. And then when p was equal to 2, we had 1 over x squared actually gave us a value, right? So naturally we might ask, well, what is the values of p for which 1 over x to the p, the integral from 1 to infinity of 1 over x to the p, is convergent? So let's consider some different cases for p. In fact, for one case we can already eliminate is the case when p is equal to 1. And this will be kind of a special case that we can eliminate here at the beginning, because we know that this case is divergent. Right? We showed that this is really just equal to the limit as t goes to infinity of the integral of 1 over x, which was ln of x, evaluated at t. So it was infinity. Okay, so it's divergent when p is equal to 1. So let's consider another case. Let's consider the case that p is greater than 1. So then when I integrate from 1 to infinity, 1 over x to the p will be the limit as t goes to infinity, integral from 1 to t. I'll write 1 over x to the p as x to the negative p. So this integral will be negative x to the negative p plus 1 over negative p plus 1, evaluated from 1 to p, or from 1 to t. And so evaluating it, we'll have t to the negative p plus 1 over negative p plus 1. Or here, actually, what I'll write is 1 over negative p plus 1 times t to the negative p plus 1. And then when I evaluate it at 1, notice that 1 to any power is just going to be 1. So minus 1. And in this case, if p is greater than 1, then I can write this as 1 over negative p plus 1 times 1 over t to the p minus 1. There I'm switching it to a negative power, or switching the sign of the power. And now if p is greater than 1, then p minus 1 is a positive power. So p minus 1 is positive when p is greater than 1. So since I have 1 over t with a positive power, this is going to go to 0 as t goes to infinity. Okay, so actually here, let's remind ourselves, we're actually taking a limit as t approaches infinity. And now we can say that this piece here goes to 0 as t goes to infinity. So now we're just left with Well, negative 1 times 1 over negative p plus 1 will just be 1 over here. That negative 1 multiplied by negative p plus 1 gives us p minus 1. So this value, when p is greater than 1, is convergent. Okay. And in fact, here we have a formula for the value of that integral when p is greater than 1. Now let's just think what would be different if p was less than 1. Well, the only thing that would be very different here would be this last step here when we said that this limit would be we would get the same valuation for the limit, but now, or for the integral, but now the limit would come out to be different. In fact, here I'm not going to flip it over. I'm just going to leave it in t to the negative p plus 1, because now when p is less than 1, the power here, negative p plus 1, will be a positive power when p is less than 1. Okay? And so this must be t to some positive power, and therefore as t goes to infinity, this whole thing here is going to go to infinity. So you got infinity minus 1, so this is equal to infinity. So that means that it'll be divergent when p is less than 1. Okay, so what we see in general is that, I'll summarize it down here, the integral from 1 to infinity of 1 over x to the p is convergent when p is less than 1 and divergent when p is greater than or equal to 1. And so in a way what we've done is we've classified all the different possible cases for this particular family of functions 1 over x to the p.